Right, let's play around with the reduction formula. I'll most certainly ask you to do something like this. So let's make sure we got it. I like the reduction formula. I teach calculus. I know the use of it. So if you're one of the students that's not going to calculus, my apologies. I don't know whether you'll ever really need this. Well, we have our two power reduction formulas, our sine squared and our cosine squared. And here's a question that I love to ask. Well, we're going to rewrite 16 times sine squared of x using the reduction formula, and I don't want sine squared. I wrote that in wrong. Hold up just a second. Oh, there it is. I want sine to the fourth of x. Using the power reduction formula as an expression with no powers greater than 1. Cool. Cool. So we're gonna want to know these two, huh? 1 minus cosine of 2x over 2 and 1 plus cosine of 2x over 2. Those are our two formulas. So let's take our problem, our exercise, our game, what have you, and let's start messing around with it. So the first thing is, let's just write it out. We see it. This is 16 times sine squared of x times sine squared of x. Oops, let me get my equal sign in there to show the logical progression all the way down. Now, we have a formula for sine squared of x, right? We got a formula for sine squared of x. 1 minus cosine of 2x over 2. So we're going to replace both of them with what they equal. 1 minus cosine of 2x over 2. 1 minus cosine of 2x over 2. Sweet, we're almost there. You're not done yet. You have certainly wrote an expression that has no powers greater than 1, but that's only because it's factored. I want to be able to expand the whole bad boy out. So let's first fraction screw us up, right? Let's get that 2 times 2, that 4 that's in the denominator. That 4 that's in the denominator. And let's see if we can't do a little canceling, right? And then leave that with a 4. Those go away. Do you see it? You could take these two 2's out. What's 2 times 2? That's 4. What's 16 divided by 4? You know it. You know it. Let's see, what's 2? So that's where that's going to go, why it's going to become a 4. All right, we rewrite it. We got 4 times 1 minus cosine of 2x times 1 minus cosine of 2x. Now here it comes. We got a FOIL. First, outer, inner, last. You've done this stuff before. Don't let the words fool you. Students complain about this every semester. They hate this. They whine and cry. See, I used to be able to see students in person. Dude, it's rough, but you practice, and then you can do it. It's not that big of a deal. I don't know. FOIL. First, outer, inner, last. So 4 times, so 1 times 1 is 1. Now we follow this one. 1 times negative cosine of 2x is negative cosine of 2x. Negative cosine of 2x times 1. Oh, that's the same thing. We got another one, so we must have 2 of them. Lastly, we have negative cosine of 2x times negative cosine of 2x. 2 negatives create a positive, so we ended up with cosine squared of shit. We got a cosine squared of 2x. Dang, we were so close. But now we have this power here. Dude, we're going to have to reduce that one. No biggie. We got cosine's formula, right? Cosine squared of x is equal to 1 plus cosine of 2x over 2. But, oh no. But there's a 2x in there. Well, wait. We're going to call this theta. Yeah, 2 theta. We just call theta equal to 2x. This one. See what sort of formula we get. So we're like, well, that would be cosine squared of 2x is equal to 1 plus cosine of over 2, and we'd have to say 2 times, 2 theta. What's that? So multiply both of them by 2. That's 4x. Oh, there it is. We can pop this piece in for cosine squared of 2x. That's the toughest part, I think. It's seeing that you got to just double the angle. So you got cosine squared of 2x. You're like, it's the same freaking formula. I just got to double up the angle. This may not make sense the first time you do it. Give yourself a break. Do the process a few times. Maybe it takes a few to catch the pattern. So we're going to now replace it with what I have in green. So that 1 plus cosine of 4x over 2. I think we really only need to do one more thing to clean it up, and let's just bring the 4 through to all the pieces and just see what happens. We get 4 minus, and that's 8 cosines of 2x. And now, I know we might struggle a little bit with this too. It's in the denominator. What's 4 divided by 2? This 4 divided by that 2 is 2. And well, this cosine of 4x. And continue cleaning just because there's stuff to put together. Two plus 4 is 6, and there is a clean answer that's completely simplified with no powers greater than 1. There's no factors, there's no anything. This is just all separated out with cosine double angles and quadruple angles and other nonsense like this. Let me give you some good news. I don't necessarily need you to get all the way down to there. I would have given you about 87.1% right there. You got to that line. Here to get to there, I give you most of your points. You're showing you know what's up. You got the thing done. The rest is gravy. That's just getting that extra little point at the end. Getting that practice. So when I test on this, it's typically some sort of combination, some number, whether it's I don't know, maybe like 32 sine squared of x cosine squared of x, and I'd ask you to play the same game. Maybe I'd ask you 8 cosine to the 4th of x, and I'd ask you to play that same game. So those would be some good example problems to try and run through and do. Notice the number I always put on the front is always going to be divisible by 4. It's actually to make your life easier, not harder, because of these two 2's that are always going to pop up down in the denominator. That's why there's a number that's divisible by 4 each and every time. That's the pattern through the game. Good luck. This is a tougher one. Pay your dues now, and it might end up making your life easier. I don't know shit. I'll stop preaching.